Hi, in this video we're gonna use Terraform to create EKS cluster in AWS, and we're gonna start from scratch. First, we're gonna use AWS console to create VPC. We're gonna create two subnets. One of them is public, another one is private. Create NAT gateways, internet gateways, and then when we're ready, we're gonna continue with Terraform. We're gonna use open source Terraform module, Terraform AWS EKS, in order to provision our EKS cluster. And well, we're gonna create two node groups. One we're gonna place in private subnet and another one in public subnet. So let's get started. Let's go to the Terraform and check the module itself. This is the GitHub page for that Terraform module. As you can see, it has a lot of stars. So let's go ahead in the AWS console. Let's go to the VPC. Like I mentioned before, we don't have any VPC right now, so we're gonna create the new VPC from scratch. To do that, let's create VPC. And I also want to mention that I'm gonna post all the commands. I'm gonna be doing it in UI manually, and I'm gonna post AWS CLI commands that can be used in order to create those VPC subnets and etc. And also Terraform for code that code can be found in my GitHub repository, and the link will be in the description. Okay, let's get started. The first thing, we want to name our VPC. We're gonna call it main. And the next, we need to define how big, how large the seeder has to be for our VPC. We're gonna be using 10.0.0.0/16, and I think it's gonna give us around 65,000 IP addresses. And the next step, well, at this point we're not gonna create any additional tags, so we're gonna leave everything as is. Let's create VPC, and it's usually very fast. So the VPC is created. We have VPC, but we don't have any subnets, anything else. The next step is to create two subnets. Let's create subnet. Let's give it a name. The first one would be public, and we're gonna be using the existing subnet that we just created. And one of the requirements for EKS cluster is to actually have subnets in multiple, at least two availability zones. So this one, we're gonna place it in 1A, and we're gonna define the seeder block. We're not gonna use the large one. We're gonna define, I think 24, right? So it's gonna give us around 256 IP addresses, and for this tutorial is enough. And well, yeah, let's create the first public subnet. Subnet is created, and the next, let's create the the private subnet. Let's call it private. And let's use our existing VPC. And like I mentioned, we need to use another availability zone. Let's use 1B. And let's use another seeder. Another 256 IP addresses. Let's create. Now we have two subnets. One of them is private, one of them is public. But right now, if you take a look, go to the routing table, you see that all of them are private right now. So there is no additional routes to go to the internet or to anything else. So the first thing, let's create a NAT gateway. Let's go to the NAT gateway. And let's create a new gateway. Let's call it my gateway. And let's pick, well, the NAT gateway has to be placed in the public subnet. So we're gonna choose the public one. And well, it's not yet technically public yet, but it's gonna be, I promise you. The public, it means the route, it has a route to internet gateway. So let's allocate IP address. We have the IP address, and let's click create. The next step would be to create internet gateway. Let's create internet gateway. Create internet gateway. My gateway. That's fine. You can call it whatever you want. Create internet gateway. Well, we just created it. The next step, let's create a new routing table. This is our default routing table, main, and we're gonna create additional one. Let's create routing table. We're gonna call it public route. That means that the default route will route to the internet. We're gonna choose our VPC and click create. And now it's created. Let's call it, this is the main one that was created with VPC. Let's call it default route, just for ourselves. And this public route we just created. And in order to make it actually public, we need to add additional default route. Let's click edit routes, add route, select 000, that means everything, all IP addresses, and click internet gateway. Well, before we can do that, we need to attach the internet gateway to the VPC. So since we just created it, we need to click actions, attach to VPC, and we need to select our VPC. Let's click attach it. Cool, now it's attached to our VPC, and now we can actually define, go to the public route, edit route, and then we can add default route to the internet gateway, right? Yeah. So here you go. Now we have the public route. Let's connect, and also, well, let's create the private route as well. So that private route will contain the NAT gateway. Let's create route table. Let's create private route. We're gonna select our VPC and then click create. And here you go. This is our private route. This is public route already completed. And this private route needs to have additional route. Let's add additional default route to NAT gateway. Let's click here, save routes. Cool. Now we have the private route with default route to NAT gateway, and we have the public route with default route to the internet gateway. And we have the main one that was created for us. Cool. Okay, so, and also I want to mention that this public route, well, let's go to the subnets and let's verify that, well, we have the public subnet and it's still we need to update the routing association. So let's click here and let's update. So this is our public, and let's pick the public route. Click save, close, and now we can see that the public subnet has the route with the default route to the internet gateway. Let's update the private subnet. Let's click edit route association, and let's update it from default to private. Here you go. Click save. And we all set. So we have the private subnet with NAT gateway, and we have the public subnet with internet gateway. And also I want to mention that for EKS, when you use Terraform module that we're gonna be using, well, all of the nodes have to have the public IP addresses. And in order to do that, one of the way is to update default subnet configuration to every new instance that you create will be assigned a public IP address. And this is actually very important for us. Otherwise, you're not going to be able to attach your instances to the EKS master, because that EKS master is the public IP address, public service. And let's click actions, and let's click on modify after assign IP addresses, and let's enable it and click save. And like I said, this is one of the options. There are other ways how you can do that, but this is the easiest one that we're gonna be using right now. So any new instance by default will get public IP address, and in the private you don't need it because it has NAT gateway. The private IP address of the instance will be translated to that NAT gateway IP address, and that way you have access to the internet, and you can actually can attach those Kubernetes nodes to the master, to the cluster. Okay, well, we all set. To summarize, we have the subnet, we have created the subnet, and we created the private and public subnets. And also, it's very important to have, public subnet. Maybe if you're not going to be deploying your instances in public subnet, but for example, you have the service, and that service in Kubernetes may use cluster, not the cluster IP, but the type of load balancer, and you want to create a public load balancer, and that public load balancer has to be placed in public subnet, otherwise it's not gonna work. And the private load balancer will be placed in private subnet. So keep in mind that in order to expose anything from Kubernetes to outside world, you may need still the public subnet for that purposes. Okay, now, well, we're gonna continue and we're gonna use Terraform to create our EKS cluster. Well, let's go to EKS, and we see that we don't have any clusters. So let's get started. The first thing for Terraform, we need to create main.tf. It can be any kind of file, any kind of name, but with a tf extension. So let's create it, and we're gonna start by defining the provider block. And we're gonna be using one of the providers that we're gonna use is AWS, and we need to define the region where we want to create our resources. And also this provider will require us credentials. So there are multiple ways how you can supply your credentials, and one of the secure way is to provide as environment variables. So you can export your environment variables, and Terraform will consume it. Okay, the next step is to define, you need to decide, first of all, what kind of backend do you want to use. Do you want to use local backend, console backend, S3 backend? Well, I wouldn't recommend to use local state, because it's going to be available only for you. And if you have multiple team members, more than you, who is working on the Terraform code, it's going to be very hard to maintain the state between all of you. So I would highly recommend to use some kind of remote state. And since we're going to be creating EKS cluster, we're going to be using S3 backend. So, well, what we need to do, we need to create the bucket, Terraform state staging, and we need to define the key. So I already created this S3 bucket, and let me show you in the console. Let's go to S3. It's very simple, just plain simple bucket. It's nothing special about this bucket. You just need to create it, and then you're gonna define where you wanna store your state, under what key, and the region for that bucket. Okay, that's done. And well, the next step, we're gonna define a couple data blocks. Data blocks is opposite to resources. So data blocks will not create any resource, any object in AWS. It will actually consume, it will retrieve some of the data from the AWS. In our case, from our module. Next, we need another provider. We're gonna be using Kubernetes provider. We need that in order to use kubectl and configure our local Kubernetes. Next step is actually to use EKS module, the main module that we have. So it's gonna start from the module EKS. You're gonna define the module, and like I said, we're gonna be using this open source Terraform module, and we have to provide a couple of the variables for that module. So let me show you again. So we're going to be using this particular module, and that's the description, how you can use it, and there are some required values that you have to provide. You can read. I'm going to link this in description as well. So the first you need to name your cluster and define the version. You can use 1.16, 1.17. At this point, 1.17 is the latest version. And next step is to define your subnets. And for EKS, you have to use at least 2 subnets in different availability zones. So let's go to the console. Let's go to the VPC. Let's go to the subnets. And well, let's take the public first. Let's grab the IP address. Let's grab the subnet ID and paste it here. And the next one will be the private subnet ID. Let's get it. Let's paste it here. The next step is we need to get our VPC ID. Let's go to the your VPC. And this is our IP. And this is our ID. Let's paste it here. Next, we gonna define 2 instance groups. And one of them would be the public. It's just a key that I specified here. And it's gonna be public just because I'm gonna place it in the public subnet. And we know that this particular subnet is the public one. So let's grab this one and let's paste it here. And we're gonna be, we're gonna ask only for one single instance. Max capacity is 10, min capacity is 1, instance type, and some of the labels that you can later use for your services as affinity. And there are more variables that you can use here. For example, let me show you node groups, and you can provide, if you go to the modules node groups, you can find all available parameters that you can use for your node groups. Same thing for the cluster. You can find all of them defined here. So we're gonna create this particular node group public, and the second one, instance group, it's gonna be private. So we're gonna go to the subnets and let's get the ID and let's paste it here. Okay, now we're done. Let's close Vim. And the first thing that you need to do is to run Terraform init. Or actually, you may want to use Terraform fmt to format your code. Let's do that. Cool. And then let's use Terraform init. Terraform init. It will download all the modules and it will prepare your Terraform. And also it will initialize the backend where it's gonna be storing the state for your EKS cluster. Okay, it's done. The next step is to run Terraform plan. And Terraform plan will show you what exactly it will create it for you. So it's gonna, most likely it's gonna create around 25 resources in AWS. Here you go, you can see that it's 24 to add, 0 to change, 0 to destroy, so it's fine. And we can verify that, well, that's exactly what we want to do. And the next step, to run Terraform apply. And it's gonna run plan first anyway, and you need to confirm then with a yes. And let's wait. Okay, well, now we want to confirm that actually we want to create all of those resources. Let's type yes. And well, it's gonna take like 10, 15, maybe even 20 minutes, depend on the load on AWS. So I'm gonna skip it and I will be back when it's finished. Okay, creation is completed. It took like 15-20 minutes. And the next step is to actually configure your kubectl. And by the way, I need to mention that one of the prerequisites is you need to install kubectl and also get command. So these two commands, kubectl and also get, has to be installed before you're gonna provision and configure your cluster. So the next step is to actually configure kubectl to work with your new EKS cluster. And to do that, we're gonna run the following command: AWS EKS region. This is our region where we just created the EKS cluster, and update config. And you need to specify your name of the cluster. And when you're gonna run it, it's gonna update, it's gonna create additional context, and you're gonna be able to access it. For example, you can run kubectl get nodes, and it's gonna list all the available nodes in your cluster. Right now it's only 2, and one of them belongs to the one instance group, to the private one, and the second one's to public one, or vice versa. I don't actually know exactly which one belongs to which one, but one instance from one instance group and another from another one. Also, you can run kubectl get svc, and you're gonna see the Kubernetes API service available. And let's go to AWS console. Let's go to the EKS cluster, type EKS, and let's select our cluster and click on compute, and you see that we have 2 managed groups. One of them is private, one of them is public. And if you click on one of them, you will see that you have the label private, and that's pretty much it. And to summarize, we just created the new VPC from scratch, and we created 2 subnets. We created 2 routing tables. We created NAT gateway, internet gateway, and configured the whole thing. And after that, we used Terraform to create EKS cluster. And thank you for watching.